If your chart refuses to grow when you add new rows, you're not imagining it. Most dynamic chart range not working problems come from one of three places. Your range isn't truly dynamic, Excel isn't recalculating the way you think, or your chart is pointed at the wrong object. The good news is you can fix this without rebuilding the chart from scratch. First, you'll learn how to diagnose what the chart is actually using as its source. Then we'll fix the classic offset approach, the more stable index approach, and the simplest option, Excel tables. Finally, we'll cover modern spill ranges from dynamic arrays, because they behave differently and they can break charts in surprising ways. By the end, you'll have a reliable method that keeps charts updating when data expands, shrinks, or gets filtered. And you'll know which technique to use for your workbook, not just what's popular. Next step. Before fixing anything, you need to confirm what the chart is truly linked to. A chart can look like it's using a column, but actually be tied to a fixed block like A2 to A13. The fastest check is to inspect the series formula. Each series has a name, X values, and Y values, and those references tell you whether the range can expand. If you see hard-coded endpoints, the chart can't grow. If you see a named range, you need to verify what that name returns. Another common trap is mixing ranges with different sizes, like X values that expand but Y values that don't. Excel may silently ignore extra points or stop plotting altogether. Also watch for blank rows. Some chart types stop at the first blank, even if your range continues. Your goal in this step is simple. Identify whether the problem is the chart reference, the named range definition, or the underlying data layout. Next step. Now let's talk about the most common dynamic range setup, a named range built with offset. Offset works by starting at a cell, then shifting and resizing based on a height and width you calculate. The usual pattern is offset start 0, 0, count a column -1, 1. When it fails, it's often because counta is counting the wrong things. It counts text, numbers, and even formulas that return an empty string. So you might be counting rows that look blank, which makes the range too long. Or you might have real blanks inside the data, which makes the range too short if you use a different counting method. Another issue is volatility. Offset recalculates frequently, which can slow large models and sometimes creates lag that feels like the chart isn't updating. Offset isn't wrong, but you need to tighten the counting logic and understand its trade-offs. Next step. If you want offset to behave, make the height calculation match your data reality. If your data is strictly numeric, count is often safer than counta because it ignores text and empty strings. If you have headers, subtract them consistently so you don't include the header row as a data point. If you may have occasional blanks, consider defining the last row by finding the last non-blank cell, not by counting. For example, you can use match with a large lookup value for numbers, or use lookup to return the last non-empty position. Then your offset height becomes last row minus first row plus 1. Also, keep the start cell anchored to the first data cell, not the header. Finally, test your named range by selecting it in the name box. If it highlights the correct block, your chart has a fighting chance. If it highlights too much or too little, fix the name first, not the chart. Next step. A lot of Excel pros prefer index instead of offset for dynamic chart ranges, because index is non-volatile in most cases. The key idea is that index can return a reference, not just a value. So you can build a range like A2 index AA last row that creates a clean, expandable endpoint without offset's constant recalculation. You still need a solid way to compute last row, but once you have it, the range is simple and stable. Index also tends to play nicer with large workbooks and multiple charts. One more advantage is readability. When you revisit the file months later, A2 index makes it obvious you're defining from the first data cell to the last used cell. If your dynamic chart range is flaky and performance matters, switching from offset to index is often the most practical upgrade. Next step. Let's build a robust last row for index, because that's where most errors hide. If your Y values are numeric, a classic method is match with a very large number, which finds the last numeric entry. If your column can include text, you can use a lookup pattern that finds the last non-empty cell. The important part is choosing a method that matches your data type. If you use a numeric method on a text column, it will stop early. If you use a text method on a numeric column with blanks, it can behave unexpectedly. Also, decide what last row means. Is it last non-blank, last non-zero, or last row that passes a filter? Charts don't automatically respect filters unless you set them up to. So define last row based on the plotted data rules, not just what looks filled. Then, plug that last row into index, and keep the chart range consistent. Next step. If you want the simplest and most reliable fix, use an Excel table. Tables automatically expand when you add rows, and charts linked to table columns usually update without any formulas. This avoids the whole last row problem. The key is to create the chart from the table columns, not from the raw range beside it. Once the chart is tied to the table, adding a new row at the bottom becomes a chart update, not a troubleshooting session. Tables also give you structured references, which reduce mistakes when you copy formulas or move columns. There are a couple of caveats. If you paste data in a way that doesn't extend the table, the chart won't update. And if you have totals rows or calculated columns, you need to ensure the chart points to the correct data column, not the totals. But for most dashboards, tables are the most dependable dynamic range strategy. Next step. Even with tables, dynamic charts can fail if the data entry pattern is inconsistent. One common issue is adding data below the table without actually extending the table. Excel usually expands the table when you type right under it, but not always when you paste large blocks. Another issue is mixing data types in a column. If numbers become text, the chart may treat them differently, and your axis scaling can look broken. Also, blanks matter. Some chart types skip blanks, others plot them as zeros depending on settings. If you're using a date column, make sure it's real dates, not text that looks like dates. Finally, if your chart is a pivot chart, tables behave differently because pivot charts depend on refresh, not just range expansion. So if you're using a table and the chart still won't update, check whether the chart is a normal chart or pivot-based, and confirm your table is truly extending. Next step. Now to modern Excel. Spill ranges from dynamic arrays. If you use formulas like filter, sort, unique, or sequence, the results spill into multiple cells. The range size can change automatically, which sounds perfect for charts. The catch is that chart support depends on how you reference that spilled output. A common approach is to reference the spill range using the hash symbol, like F2 hash. That tells Excel, use the entire spilled range starting at F2. If your chart isn't updating, it's often because the chart is pointing to a fixed range next to the spill, not to the spill itself. Another issue is that spill ranges can change shape. If your X values spill to 20 rows, but your Y values spill to 19, the chart will error or silently drop points. With spill ranges, consistency is everything. Same height, aligned rows, and stable output types. Next step. Let's make spill-based charts robust. First, keep the spill outputs in dedicated columns with no manual entries below them, because anything in the spill area causes a spill error and your chart loses its source. Second, ensure both axes are driven by the same filter logic. If you filter X from one table and Y from another, they can return different row counts. Third, stabilize empty results. Filter can return no results, and then your spill range might become a single-cell message. Charts don't like that. A better approach is to return blanks of the expected shape, or to wrap the chart source in a helper range that always has a predictable structure. Finally, if you need a single-column series, make sure your spill is exactly one column wide. Multi-column spills can create multiple series unintentionally. With these guardrails, spill ranges become a clean, modern dynamic chart source. Next step. Sometimes the range is fine, but the chart still doesn't update. That's usually recalculation or refresh behavior. Normal charts update when their source cells change, and calculation runs. If calculation is set to manual, you can add rows and nothing moves until a recalculation happens. Another scenario is external connections or Power Query outputs, where the data changes only after a refresh. Pivot charts are the biggest source of confusion here. They don't expand because a range expanded. They expand because the pivot cache refreshed and the pivot table included new items. So the fix isn't offset or index. The fix is making sure the pivot source includes the new rows and then refreshing. If you're troubleshooting, identify the chart type first: standard chart, table chart, or pivot chart, because each one updates for different reasons. Next step. Another reason dynamic chart ranges fail is messy data structure. Charts behave best with a clean, contiguous dataset. One header row, no merge cells, and consistent columns. If you have blank rows separating months, your lastRow logic might stop early, and some charts stop plotting at the first blank. If you have extra notes in the same column, Counta will count them and extend the plotted range into non-data. If you have duplicate headers or multiple header rows, tables and structured references can misbehave. The practical fix is to separate concerns. Keep raw data in a simple table. Put notes elsewhere. If you need spacing for readability, use formatting, not blank rows. And if you need multiple sections, use multiple tables and combine them with Power Query or a dynamic array formula. A clean layout makes every dynamic technique, offset, index, tables, and spills, more predictable. Next step. So which method should you choose? If you can, start with an Excel table. It's the least fragile and the easiest to maintain. If you can't use a table, index-based named ranges are a strong second choice, especially in larger workbooks where performance matters. Offset still works, but treat it as a legacy tool. Use it when you truly need its ability to return a resized block, and keep the counting logic tight. For modern models built on filter and sort, spill references with the hash symbol are great, but only if you control shape changes and no result cases. The bigger point is consistency. Your chart needs a predictable X range, a predictable Y range, and a reliable definition of lastRow. Once you pick one approach and apply it cleanly, dynamic charts become boring. Next step. To wrap this up, here's a quick troubleshooting order that saves time. First, confirm the chart series references, because many problems are just fixed endpoints. Second, decide whether you're dealing with a normal chart, a table-based chart, a pivot chart, or a spill-driven chart, because the update rules differ. Third, fix the source. Table columns if possible, index-based named ranges if not, and offset only when you have a specific reason. Fourth, clean the data layout so blanks and notes don't confuse your lastRow logic. If you want, share your setup in one line. Are you using offset, index, a table, or a spill range A or B? And if you want more Excel troubleshooting like this, hit subscribe once so you don't miss the next one. Small tweaks compound into massive performance gains. Subscribe to catch the next workflow optimization.